Good morning everyone, my name is Maria and I'm honored to present today on behalf of HEDNO. This presentation is part of the Area Grid 2 MOOC, specifically Module 6, which focuses on industry engagement and the critical role laboratories play in advancing research and technology for industrial applications. We will be diving into lab access activities by various industry participants under the Area Grid 2 framework. Throughout this presentation, I will introduce you to key projects, highlight the companies that benefited from lab access, and discuss the valuable research outcomes that resulted from these collaborations. Each project reflects the importance of controlled testing environments in validating new technologies before they are implemented in real-world power systems. As of the preparation of this module, Area Grid 2 has received a total of 23 user proposals with industry participation. Out of these, 16 projects have been led by industry organizations, accounting for 21% of all user projects under the program. This highlights a strong commitment from the industry to engage in advanced research and development within Area Grid 2. So far, 14 of these projects have been completed across various European laboratory infrastructures, providing a total of 209 access days to 29 industry users. This level of access has enabled companies to test, validate, and refine their technologies in highly controlled settings. Looking ahead, by the end of Area Grid 2, an additional 146 access days will be provided to industry organizations through 9 more projects currently in progress. This sustained engagement underscores the growing need for research-driven industrial solutions in the evolving energy landscape. One of the companies that has actively participated in Area Grid 2 is Rosso Technologies, a French software startup specializing in software and electrical engineering. Their work focuses on developing innovative solutions for energy networks, particularly in the area of non-firm grid connections for low-voltage networks. A key achievement of Rosso Technologies is the development of Grid Expander, a software designed to optimize the use of existing smart metering infrastructure to improve grid flexibility. To ensure that their software operates effectively under real-world conditions, they initially tested it within their own laboratory before moving it to a more advanced validation process at the SISTEC lab in Kassel, Germany. This partnership allowed them to verify the performance of their software in a highly sophisticated lab environment. Through the Area Grid 2 Lab Access Program, Rosso Technologies was able to conduct a detailed evaluation of their software in an electric network that closely resembles a real distribution grid. This real-world simulation was crucial in identifying potential operational challenges and ensuring that the software could effectively support non-firm grid connections. Collaboration with SISTEC engineers and researchers was instrumental in this process. Their expertise helped Rosso Technologies configure the network, install project-specific equipment, and troubleshoot deployment issues. Additionally, hands-on testing in SISTEC's advanced infrastructure provided insights that would not have been possible in a conventional laboratory setup, highlighting the value of international research collaboration. ABB, a multinational corporation specializing in power systems, automation and robotics, is another major industry participant in Area Grid 2. Their research focused on validating new functionalities in optimization, forecasting and microgrid operation, aiming to simulate real microgrid conditions as closely as possible. The project had 2 primary components. The first, EM Core, centered on optimization and forecasting for enhanced energy management. The second component, PCC, focused on evaluating how predictive control could improve microgrid efficiency. These functionalities were rigorously tested in a modern predictive control setup at the RSC lab, providing ABB within a robust environment to assess the performance of their technology before deployment in live energy networks. The research at RSC in Milan was highly productive. M-course optimization and forecasting models were tested extensively under different microgrid operating conditions. Most of the results were positive, demonstrating significant potential for improving microgrid operations. However, one of the key challenges was the computationally intensive nature of the training phase, which required additional optimization. Despite this, the technical setup in the lab proved highly efficient, allowing ABB to conduct tests seamlessly. Having consistent access to technical support was also a major advantage, enabling researchers to clarify uncertainties and refine their models in real time. This case underscores how control lab environments play a crucial role in developing reliable and scalable industrial solutions. CEPEL, a Brazilian research institution established in 1974, is another notable participant in ERGRI-2. Their focus is on electrical energy research, particularly in testing and validating power hardware in the loop field systems. These advanced test benches allow engineers to analyze hardware and software interactions in a highly controlled environment. Field testing is critical in power system research because it enables validation of real hardware in simulated grid conditions. This approach provides a cost-effective and efficient means to verify the performance of new technologies before deploying them in actual networks. CEPEL's participation in ERGRI-2 provided them with access to world-class field testing facilities. Through the ERGRI-2 Lab Access Program, CEPEL had the opportunity to test and compare two distinct field setups. Their modified test bench was deployed at the Electrical Sustainable Power Lab, ESP Lab, at Delft University of Technology, leveraging the lab's advanced infrastructure and resources. This collaboration allowed CEPEL to refine their field system and compare its performance under different operational scenarios. The testing process provided valuable insights into the effectiveness of their technology, helping them optimize the setup for future real-world applications. Such research demonstrates the vital role that laboratory-based experiments play in the advance of power system technologies. ENEIDA, a company specializing in operational analytics, also benefited from ERGRI Lab Access Program. Their research aimed to address a pressing challenge faced by distribution system operators: the rapid detection and localization of faults in low-voltage networks. Traditional fault detection methods can be slow and costly, making it difficult for DSOs to respond effectively. To tackle this issue, ENEIDA explored impedance-based fault detection methods, both single-ended and double-ended. Their goal was to develop an efficient solution that could improve response times and reduce operational costs. To validate their approach, ENEIDA conducted a user project titled Fault Troubleshooter (FaultTS) at PNDC from February 7 to February 10, 2013. The project involved controlled short-circuit experiments under varying fault-resistant conditions. The findings from these experiments provided valuable insights into the accuracy and reliability of different fault detection techniques. The data collected is now being used to refine fault localization strategies, ultimately helping DSOs improve grid reliability and reduce downtime. This project serves as yet another example of how ERGRI-2 supports innovation through real-world testing. In conclusion, the ERGRI-2 Lab Access Program has been instrumental in fostering industry-driven research and accelerating technological advancements in power systems. Through collaborations with leading companies like Rosso Technologies, ABB, CEPEL, and ENEIDA, this initiative has enabled real-world testing of innovative solutions in highly controlled lab environments. These partnerships not only enhance industry research, but also contribute to more resilient, efficient, and intelligent power networks. Thank you for your time, and I look forward to your questions.